previously we went ahead and talked about the three main trig ratios being sine, cosine, and tangent. And specifically, we talked about that sine is our opposite over hypotenuse, cosine is our adjacent over hypotenuse, and tangent is opposite over adjacent. So we learned about SOHCAHTOA, those three main ratios. Today we are going to continue using those three main ratios, but we'll also talk briefly about complementary angles. Complementary angles are angles that add to 90 degrees. So in a right triangle, well, in any triangle, in fact, all three angles, so angle A, B, and C, should add up to 180 degrees. Angle C is always our right angle. So rather than putting C right here, I'm going to go ahead and change C to be 90, since it's always 90 degrees. And then if you subtract 90 from both sides, you'll notice that angle A plus angle B is always 90 degrees, meaning angle A and angle B are complementary angles. So because those two angles are complementary, like they stated right here, we can say the following. So we can say that sine of angle A is actually equivalent to cosine of angle B, because angle A and angle B are complementary angles. And you can say that for any of the complementary angles. Switch it up, you can see right here. Now, I'm going to talk about why that's true. So I'm specifically going to prove or explain why sine of angle A is equal to sine of angle B, sorry, not sine, but cosine, by using this diagram and reviewing our SOHCAHTOA principles, specifically just the sine and the cosine principles. So our SOHCA. So here we go. We've got angle A is right here. Across from angle A is always your side A. Across from angle B is always side B. And across from angle C is always side C. Angle C is our right angle, so that means this right here is our hypotenuse. So we know that sine of angle A is equal to our opposite side, so our O. The opposite is our A, side A. And the hypotenuse is side C. Then we also know that cosine of, we're now going to switch angles, oops, angle B right here. There we go. So cosine of angle B is equal to our adjacent side. The adjacent side to angle B is side A. So notice how for A was opposite for angle A, but it's adjacent to angle B. And then our hypotenuse is C. As you can tell, those are both equal, which is why you can say that sine of angle A is equal to cosine of angle B. So if we use this in context, you can imagine it as a right triangle. You can do this a few ways, so I'll show you the right triangle way. So if I had a right triangle, and let's say this is a 9-degree angle, if we're trying to write this in terms of cosine, then we go ahead and find this angle right here by doing 90 minus 9 degrees, which is 81 degrees. So you could write this as cosine of 81 degrees. And that's going to work, that process is going to work for all of these. So even for this, whether you draw the triangle or not, if we have 30 degrees right here, then this angle needs to be 90 minus 30 degrees, which is 60 degrees. So we can say this is cosine of 60 degrees. So like I said, you don't actually have to draw the triangle. It's always going to be the complementary angle. So 90 minus 77 is 13 degrees. So we have cosine of 13 degrees for this problem. Now to go backwards, it's pretty quick, so I will go through these kind of quick. Hopefully that's not too much of a problem for you. But it's the same idea if you're switching to sine. So, and I'll even draw the triangle again, even if we say this is, let me make that a little cleaner looking. There we go. This is 15 degrees. So you're still finding the complement, which is 90 minus 15, which is 75 degrees. So cosine of 15 degrees is the same as sine of 75 degrees. So it shouldn't be anything too crazy. So we've got 90 minus 83, which is 7 degrees. So this is sine of 7 degrees. And then the last one, 90 minus 45 is 45 degrees. So this would be sine of 45 degrees. So that's how you switch between sine and cosine. Nothing too crazy. You're just always using the complementary angle, meaning you're always subtracting from the given angle from 90 degrees.